Y'all ready?
Yes, sir.
We will be launching the rocket in 10 minutes. Be prepared. Aye, Captain. I think we have a problem. The direction of our rocket launch has been screwed up. What do we do? None of us knows how to fix this. Only? Yes, indeed. There's really only one penguin in this world that we can call
Super Pengy.
No need to fret, my fellas. I am ready. No. What's the problem?
Here's our current data on the asteroid right now. The current functioning of our ship only allows us to print and display this in rectangular form, and as you know, all of the Meteor Destroyer 3000's calculating functions do not work at this point. The point we've predicted on this map is our location in 10 minutes on our originally planned course. I'm sorry to say, but after that time we may not have many more chances to destroy it.
Hoo-hoo. Not a problem. Not a problem at all. As you can see, I am the pupil of the all-famous mathematician, Master PreCalc. Watch very closely, my penguin comrades. So, the coordinates of the meteor from our ship at that point would be 72.3692 kilometers to the east and 41.3110 kilometers north. So, our coordinates will be 72.3692, 41.3110. The best way to find the firing power and angle we need would be to convert this data into polar form.
What's polar form?
Look here. While in rectangular form, the coordinates are placed on a plane based on a rectangle. On the other one, polar coordinates are based on a radial graph, and they describe the angle and distance from the origin of a point. This point can be expressed as r theta, in which r is the length from origin and theta is the angle from the polar axis. To convert from rectangular form to polar form, we use this formula. The r value would be square root of x squared plus y squared, comma. The theta would be inverse tangent, negative y over x. We plug in the values into this equation to get our polar coordinate.
Oh, I see. So we would have the equation, parentheses open, square root of 72.3692 squared plus 41.3110 squared, comma, inverse tangent of negative 41.3110 over 72.3692, parentheses closed.
Precisely. So, here's how we do the work. Under the square root for the r value, we would get 5,237.301109 plus 1,076.598721, which equals 6,943.89983. The root of that, according to our calculations, would be 83.33006558. That would be the distance of our ship from the meteor. For the theta value, we're going to have to do a little bit of trigonometry. Make sure your calculators are set for degrees. We would simply plug in the expression that Lavangi presented just a second ago, and we would get 29.7193 degrees.
Wow.
I guess it's my time to head up. The clock is ticking after all.
Wait, Super Pengy, another problem has occurred. A gust of unexpected astronomical force is disrupting the direction of our spaceship. It's coming at a speed of 500 miles per hour with a bearing of 40 degrees.
Oh no! The world is ending again!
Hey! Do not fear, for there is a solution to this as well. Look here. The spaceship needs to reach this origin point in order to properly shoot down the meteor. So right now, we want to go straight east at the speed of
17,500 miles per hour.
All right. So our desired direction and speed of the spaceship is 17,500 miles per hour with an angle of 0 degrees, and the astronomical force is 500 miles per hour with a bearing of 40 degrees. But hey, don't forget that the bearing angle is different from the polar angle. In order to solve this equation, the astronomical force's direction must be expressed in polar angle. So then, we will convert 40 degrees with the formula 90 degrees minus bearing of theta, and the answer is 50 degrees. Now we'll use another formula. Spaceship speed cosine unknown direction, comma spaceship speed sine unknown direction, plus astronomical force speed cosine astronomical force direction, comma astronomical force speed sine astronomical force direction. This equals the unknown speed cosine desired direction and comma unknown speed sine desired direction. After that, you split the equation into two like this. The first one is 17,500 sine unknown direction plus 500 sine 50 degrees equals unknown speed sine 0 degrees. The second one is 17,500 cosine unknown direction plus 500 cosine 50 degrees equals unknown speed cosine 0 degrees. Make sure to solve the sine one first and find out the intended direction. Now, look at this equation and simplify. Yup, the unknown direction is negative 1.2541 degrees. Then, solve the cosine one and find out the intended speed. Oh, but make sure to put the unknown direction into the equation here. We get 17,817.2019 miles per hour. Aye, now we got the solution. Alright, so then we set up the spaceship to go at the speed of 17,817.2019 miles per hour at the direction of negative 1.2541 degrees.
I'm getting right to it.
Beep beep boop bop beep.
Angle is currently being set by controller. 86% accuracy. 96% accuracy. A bit more to your left, Pangy, and that's perfect! 100% accurate to the predicted angle.
Hasta la vista!
Brrr, boom!